Hello students, thank you very much for today's class. Today class we will study about the swing equation. So what is swing equation? Actually the swing equation is used to understand the dynamics of a rotor in a synchronous machine during any disturbance. सो स्विंग इक्वेशन एक ऐसी इक्वेशन है जो कि आपको रोटर की डायनेमिक्स को अंडरस्टैंड करने में हेल्प करती है कब जब रोटर के ऊपर किसी किस्म की कोई डिस्टर्बेंस आती है। तो ये डिस्टर्बेंस एक स्मॉल डिस्टर्बेंस भी हो सकती है और ये डिस्टर्बेंस एक लार्ज डिस्टर्बेंस भी हो सकती है। स्विंग इक्वेशन कहाँ पे है देखिएगा, यहाँ पे पहले मैंने आपको स्विंग इक्वेशन मेंशन कर दी बोर्ड पे। दिस इज नाउ द स्विंग इक्वेशन 2h over omega s times d square delta by dt square is equal to Pm minus Pe, where h is inertia constant or movement of inertia. Then we have omega s, which is the synchronous frequency or speed of a machine. Then we have the acceleration d square delta over dt square, and then we have mechanical and electrical power. So the equation that basically show you how the rotor dynamics change, how the acceleration of rotor is affected with any disturbance in the machine is known as the swing equation. So if we look at the left hand side of this equation, this equation clearly indicates that this is an acceleration. What is an acceleration? The change in speed of a synchronous machine. So this is basically the change in the speed or the acceleration gained by the rotor of a generator. So this equation is indicating that is basically depending on the inertia of the machine. So if we have high inertia, then it means that our acceleration should be low. So the change in the speed of the machine will be less if the machine has a higher inertia. Similarly, if the value of h is low, then automatically the acceleration will be more. So this equation also indicates you the relationship between the inertia of a rotor and the acceleration gained by the rotor in case of any disturbance. So now I will drive this equation for you in this class, and ultimately we will end up with this equation after having this whole derivation. So the equation or the derivation of the swing equation starts by applying the Newton's second law to the rotor of synchronous machine, describing its rotational motion. So what is Newton's second law of motion? Newton's second law of motion for rotational machine is basically torque, which is T is equal to J alpha, fine, where J is moment of inertia of the rotor, alpha is angular acceleration. So you know that angular acceleration, if we write it in terms of angular displacement, so it will be the double derivative of angular displacement. Therefore, we have written this thing over here. So then torque is equal to T, torque is equal to J times moment of inertia of a rotor times d square theta m by dt square, as alpha is equal to d square theta m by dt square, where theta m is the mechanical angular position of a machine at any point during its rotation. So now, and again d square theta m by dt square is basically it is a double derivative of that theta m, and it is representing the acceleration of a machine. So now what will be the net torque on a rotor? The net torque of the rotor of any synchronous machine is T net is equal to Tm minus Te, where Tm is the mechanical torque of a machine and T is the electrical torque of a machine. So now we will apply Newton's law here. If we will apply Newton's law here, so as we know that Newton's law represents T is equal to J times d square theta m by dt square. So we will replace T on the left hand side of this equation torque by the net torque, which is Tm minus Te. So right now here on this here we are writing it on the right hand side of this equation. So the net torque is represented by Tm minus Te, and on the left hand side we are writing this J d square theta m by dt square. So now we will convert this torque, the equation of torque, into equation of motion, power, sorry. How we can convert this equation of torque into equation of power? We can convert by simply multiplying this equation by omega m, as we know that torque is equal to, as we know that P is equal to torque times omega, or torque is equal to P over omega. So therefore what we are doing is that for converting this equation into the equation of power, we are simply multiplying this equation with the angular velocity omega m. So here we have multiplied this. So this equation becomes j omega m d square theta m by dt square is equal to omega m times Tm minus Te. So after this, we will transform these mechanical rotations and mechanical angles or mechanical frequencies into electrical frequencies. So how can we do that? We can do it by simply, because we know that from the last lectures of stability, there, as we know that omega E is equal to P by 2 omega m. Similarly, if omega E is equal to P by 2 omega m, similarly we have theta E is equal to P by 2 theta m. So if we have a two pole machine, number of poles 2, so then we can say that theta E is equal to theta m. So for a machine with two number of poles, theta E will become equal to theta m. We were discussing that now we have to transform from theta m to theta e, I mean from mechanical rotation to electrical rotation. So for that purpose, we know that theta e is equal to p by 2 theta m, and therefore if we have a number of poles 2, then theta is equal to theta m. Similarly, omega e is equal to p by 2 omega m. So if we have number of poles 2, then omega e is equal to omega m. So the same thing repeat here, because theta is equal to theta m, we know that Pm mechanical power is equal to torque multiplied by mechanical speed. Similarly, electrical power is equal to electrical torque multiplied by actually electrical speed, but as we know that electrical speed is equal to now mechanical speed for the machine having number of poles 2, therefore we say that omega s is equal to omega m, so P is equal to T is omega m. So using this relation, Pm is equal to Tm omega m and T is equal to Pe is equal to T omega m, using the previous equation that we have written on the board previously, we will replace the T is there, and the final equation will become now j omega s d square theta e over dt square is equal to Pm minus Pe. You also know that we have before we have written d square theta m over dt square. Before that, we have written this thing j d square theta m over dt square, and we have with us omega s as well. Sorry, for that we have omega m. So we have converted from theta m to theta I. We know that as theta m is equal to theta I, we have replaced theta m with theta I, and we know that omega m is equal to omega s for a two pole machine. Therefore, we have written omega s is equal to omega m here. So therefore, the equation that we have previously written for mechanical angular motion, we have now written this for electrical angular speed. So therefore, now it has become j omega s d square theta I over dt square is equal to Pm minus Pe. Now we know that angular momentum m is equal to j omega s, and the change in angle delta is equal to theta et minus omega st from our previous lecture. So if we take the double derivative of this equation, it will become d square delta over d square theta I over dt square, and this equation will, I mean this part will fade off, this part will not be there. So it will become d square delta over dt square is equal to d square theta I over dt square. Now replacing d square theta I over dt square in this equation, it will become j omega s d square delta over dt square. So j omega s d square delta over dt square, also replacing j omega s with m. So the equation will become m d square delta over dt square is equal to Pm minus Pe. Now, if we want to express this equation in form of per unit, and before doing that, first we will convert inertia. So what is the actually inertia? The inertia constant can be represented with the help of the equation H is equal to half j omega square divided by s base. So we can write j is equal to 2h s base divided by omega s square. Fine. Okay, now we will add the component of inertia constant and write the swing equation in the form of inertia constant. So what is the formula for inertia constant is H is equal to half j omega s square s base, and we are also writing this form in the form of per unit system. Fine. So that's why we have added s base here, because it makes it in the form of per unit. So after having h is equal to half j omega s square divided by s base, we will write this equation in the form of j. And why want to write it in the form of j? Because in the actual swing equation that we have derived in the previous step, there we have a j in the equation because m is equal to j omega s. So that's why we are trying to write this equation in the form of j. So after here, we have simply written this equation in the form of j. J is equal to 2h divided by omega s square multiplied by s base. So now we have the value of j. Putting this value of j in this equation, which we have derived in the previous step, m d square delta by dt square is equal to pm minus pe. As you know well, m is equal to j omega s. So now if we replace m with j omega s, so now m replaced with j omega s, the equation will become j omega s d square delta by dt square is equal to pm minus pe. So again, we know that from this equation j is equal to 2h over omega s square times s base. So we have simply replaced j from this equation here in this equation, and right now we are not writing s base here because we are understanding this thing that this equation is already in per unit. So if we write here per unit in front of this equation, so it is understood that it is in per unit, so there is no need to write s base with this equation. Fine. So that's why we are simply writing this in this form. So replace j here in this equation from here. It will become 2h over omega s square, omega s d square delta by dt square is equal to pm minus pe. So after writing it here, we will cancel the omega s by omega s square. So only we are left with omega s in the denominator, and the final form of the equation will become here 2h over omega s d square delta by dt square is equal to pm minus pe. This is the same equation that I show you in the start of the lecture. So now if we want to write this equation by considering the damping effect of the generator as well, because this form of swing equation is not actually a realistic representation of synchronous generator, because if we write the synchronous equation in this form, this will represent you that your generator is in the swing mode. अगर हम इसको ऐसे ही लिखते रहेंगे जैसे कि यहाँ पे लिखी हुई है, अभी जो फॉर्म है स्विंग इक्वेशन की, ये आपको ये बता रही है कि आपका जनरेटर जब उसके ऊपर कोई डिस्टर्बेंस आई तो उस डिस्टर्बेंस आने के बाद क्या हुआ, जनरेटर एक्सेलरेशन गेन की जनरेटर ने। स्विंग इक्वेशन क्या बताती है, जैसे कि मैंने एक लेक्चर के स्टार्ट में आपको बताया था, वो आपको ये बताती है कि जैसे ही डिस्टर्बेंस आपके जनरेटर के ऊपर आए, देन हाउ मच योर रोटर स्विंग्स फ्रॉम इट्स सिंक्रोनस पोजिशन. So the angle at which your rotor swings from its synchronous position, that angle is explained with the help of swing equation. Fine. So अगर तो आपका एक ऐसी मशीन है जो कि जिसके अंदर डैम्पिंग का इफेक्ट जीरो है, अगर कोई ऐसा सिंक्रोनस जनरेटर आप बना लें जिसके अंदर डैम्पिंग क्या है, जीरो है, तो फिर तो उस जनरेटर को तो ये स्विंग इक्वेशन रिप्रेजेंट कर सकती है। लेकिन उस केस में क्या होगा, अगर आप डैम्पिंग का इफेक्ट जीरो होगा किसी भी सिंक्रोनस जनरेटर में, इट मींस कि आपका इनर्शिया जीरो है जनरेटर का, अगर वो डैम्पिंग आपको जीरो दे रहा है। तो अगर किसी जनरेटर का डैम्पिंग जीरो है, तो अगर उसके ऊपर किसी किस्म की कोई डिस्टर्बेंस आती है तो क्या होगा, जनरेटर उस डिस्टर्बेंस को रिस्पॉन्ड बैक नहीं करेगा, और जब जनरेटर उस डिस्टर्बेंस को रिस्पॉन्ड बैक नहीं करेगा तो आपका जो सिस्टम है वो ऑटोमेटिकली दोबारा क्या नहीं होगा, स्टेबल नहीं होगा। एग्रीड। तो फिर क्या, हमें इस वजह से अपने सिंक्रोनस जनरेटर के अंदर डैम्पिंग को रखना पड़ता है, और उस डैम्पिंग को रखने के लिए हम जनरेटर के अंदर एक वाइंडिंग रखते हैं, उस वाइंडिंग को हम कहते हैं डैम्पिंग वाइंडिंग। सही है। तो सिंक्रोनस जनरेटर में एक ऐसी वाइंडिंग होती है जिसका नाम होता है, एक तो फील्ड वाइंडिंग, एक आर्मेचर वाइंडिंग, और एक और वाइंडिंग होती है जिसको हम कहते हैं डैम्पर वाइंडिंग। वो जो डैम्पर वाइंडिंग होती है सिंक्रोनस जनरेटर में, बेसिकली वो क्या बनाती है, वो बनाती है डैम्पिंग इफेक्ट, और वो डैम्पिंग इफेक्ट अपोज करता है किसको, कोई भी अगर डिस्टर्बेंस आती है आपके सिस्टम के अंदर, और उस अपोजिशन की वजह से आपका जो जनरेटर है दोबारा क्या रीगेन कर लेता है अपनी स्टेडी स्टेट या सिंक्रोनिज्म। तो अगर तो हमने डैम्पिंग इफेक्ट को कंसीडर नहीं किया एक जनरेटर के अंदर, तो आपकी जो ऑसिलेशन आई है या जो डिस्टर्बेंस की वजह से जो ऑसिलेशन आई है, इट विल रिमेन ऑलवेज देयर। बिल्कुल ऐसी जैसे कि कोई पेंडुलम है, अगर पेंडुलम को आप दरमियान में कोई फ्रिक्शन नहीं मिलेगी किसी क्लॉक पेंडुलम को, तो क्या करता है, हर वक्त ऐसे ऐसे हैंगिंग मोड में रहेगा ना। इसी तरह अगर आपके जनरेटर को भी कोई सामने से अपोजिशन नहीं आ रही, या उसकी इस जो डिस्टर्बेंस है जिसकी वजह से ये ऑसिलेट करना स्टार्ट हुआ है, जिसने उसने एक्सेलरेशन और डिसलरेट हो रहा है, अगर इसको दरमियान से कोई डैम्पिंग नहीं आएगी तो क्या होगा, ये कॉन्टिन्यूसली डिस्टर्बेंस या एक्सेलरेशन और डिसलरेशन मोड में रहेगा और स्विंग करता रहेगा, कभी इधर कभी इधर कभी इधर कभी इधर, ऐसे ही रहेगा। तो इस स्विंग को रोकने के लिए व्हाट वी वांट इज दैट कि हमारी ये स्विंग ना हो। इस स्विंग को रोकने के लिए हम क्या करते हैं, अपने जनरेटर्स के अंदर कौन सी वाइंडिंग ऐड करते हैं, डैम्पर वाइंडिंग। अब डैम्पर वाइंडिंग का इसका मतलब है कि इफेक्ट हमें कंसीडर करना है अगर हमने एक रियलिस्टिक फॉर्म ऑफ स्विंग इक्वेशन लिखनी है। तो टू हैव अ रियलिस्टिक फॉर्म ऑफ स्विंग इक्वेशन हमें क्या करना पड़ता है कि डैम्पर वाइंडिंग के इफेक्ट को कंसीडर करना पड़ता है, और फिर आपकी जो स्विंग इक्वेशन है वो सिंपली इस तरह नहीं लिखी जाती, बल्कि आपकी स्विंग इक्वेशन जो है वो इस तरह रिप्रेजेंट की जाती है। लेकिन मोस्ट ऑफ द बुक्स यू विल फाइंड कि आपकी स्विंग इक्वेशन जो है वो इस फॉर्म में है। उसकी रीजन ये है कि फॉर द अर्ली लर्नर्स, सेकेंडली ये कि फॉर द सेक ऑफ द सिंप्लिसिटी, एंड फॉर टू अंडरस्टैंड कि आपकी रोटर डायनेमिक्स होती कैसी है, कि आपका जो रोटर है वो कैसे रोटेट करता है आपकी डिस्टर्बेंस के साथ। सो उसको अंडरस्टैंड करवाने के लिए हम क्या करते हैं, दिस इज अ सिंप्लीफाइड ऑफ स्विंग इक्वेशन जिसको हम रिप्रेजेंट करते हैं। आई होप कि स्विंग इक्वेशन आपको समझ आई होगी। इन द नेक्स्ट लेक्चर वी विल स्टार्ट विद द स्मॉल सिग्नल स्टेबिलिटी एनालिसिस ऑफ अ मशीन। थैंक यू वेरी मच।